This video goes over the distributive property. Here we're going to use our power rules as well as our multiplication and division facts. So let's start by doing some simple expanding. So where we're going to start is we're going to take the number that's outside the brackets and we're going to multiply by whatever is inside the brackets. So in my first one, I've got 3 outside. So I'm going to take 3 and multiply it by x and multiply it by 2. I've got 2 terms inside my brackets, so I should end up with 2 terms after I expand. 3 times x is 3x, 3 times 2 is 6. Let's look at the second example here. I've got a 6 outside, and I've got 3 terms inside the brackets. So I'm going to take my 6, and I'm going to multiply it by each of those 3 terms. 6 times minus 2 is minus 12x. 6 times 3 is 18. Then with the y, 6 times minus 4 is minus 24. This is my expanded version. I've distributed by getting rid of the brackets. In my third example here, I'm going to take the negative that's outside, and I'm going to multiply it by both terms inside. The effect that that has is just changing the sign on both of those terms. Looking at the next one, here I've got a negative and a number. So I'm going to take that, multiply it inside my brackets. I don't have to multiply minus 5 by minus 4 because the minus 5 is not inside the brackets. So let's distribute first. Minus 4 times minus 3x is 12x. And then minus 4 times 2y is minus 8y. And then I still have the minus 5 at the end. I've successfully distributed and I know that I've done that because my brackets are gone. And I can't simplify any further because none of those are like terms. Here in example F, I have a number and a variable outside. So I'm going to take that, multiply it by my first term, and multiply it by my second term. 3m times 5m is 15m squared. Remember our adding powers, multiplying powers with the same base, we add the exponents. And then 3m times 2 is 6m. In example G, we've got a variable outside, so we're going to need to remember what we do when we're multiplying powers that have the same base. Y times 4y is just 4y squared, and y times minus 3 is just minus 3y. Let's look at a couple more examples here. Okay, example H. Here I've got a negative sign and a variable and a number. So I'm going to take that whole monomial outside and multiply it by each of the terms inside my brackets. Minus 6a times 4 is minus 24a. Minus 6a times 3a is minus 18a squared. And then minus 6a times minus 2a squared is plus 12a cubed. And for my final answer, I should write them in order of descending powers. So with my a cubed term first. Sort of like starting a sentence with a capital letter. In example C, D, and E, here I've got multiple terms. So in example C, I've got 2 brackets that I need to expand, or 2 terms that I need to distribute. So that 3 applies to the 4a minus 2b and 3c. The minus 4 applies to the a, the 3b, and the minus 5c. So let's look at that first one. 3 times 4a is 12a. 3 times minus 2b is minus 6b. 3 times 3c is plus 9c. In my second part, I need to remember that I am multiplying minus 4, that's the number that's outside the brackets, by each of the terms. So minus 4 times a is minus 4a. Minus 4 times positive 3b is minus 12b. And then finally, I've got minus 4 times minus 5c, which is plus 20c. Now I've got 6 terms. I want to check and make sure that I've simplified fully, so now I'm going to look for my like terms. So I've got 2 a's, I've got 2 b's, and then I've got 2 c's. So in order to simplify my expression, I'm going to combine those like terms. Starting with the a's to go in alphabetical order. So 12a minus 4a is 8a, minus 6b minus 12b is minus 18b, and finally 9c plus 20c is plus 29c. Let's look at example D. In D, I've got 3 brackets. So the 5 applies to the 2m squared and the minus 3. The 4 applies to the 3m squared and the 10. And then the minus sign, or the minus 1, applies to the 6m squared minus 5. So expanding that first bracket, we get 10m squared minus 15. Second bracket, we get 12m squared plus 40. And expanding the third bracket, we get minus 6m squared plus 5. Next step is to identify my like terms. I've got m squared, and m squared. And then I've got minus 15 plus 40 plus 5. So my final step is to collect those like terms together. For the m squareds, I've got 10 plus 12, which is 22. 22 minus 6 is 16. And then for my numbers, I've got minus 15. Let's see, plus 5 would give me minus 10. And then minus 10 plus 40 would give me plus 30. That's my final simplified expanded expression. The last one actually only has one set of brackets to expand in the middle. That 4m applies to the m and the minus 3. It doesn't apply to the 11m, which is after, or the 2m squared, which is before. So when I expand this expression, I get 2m squared plus 4m squared minus 12m plus 11m. Identifying my like terms, I've got m squared, and then I've got minus 12m and plus 11m. Finally, this gives me 6m squared minus m, or minus 1m. So let's look at our last one here. And here we're just going to do some examples of division. So when you're dividing, the same principle applies. You're going to take the number that's on the bottom, and you're going to divide both terms on the top by that number on the bottom. So 7m plus 14 over 7 is the same as 7m over 7 and 14 over 7. Now I'm going to divide those numbers. 7m divided by 7 just gives me m, and 14 divided by 7 gives me 2. Similarly here, I can split this into 24x over 6 minus 18y over 6. In this case, I'm only really dividing the numbers. So 24 divided by 6 is 4x. 18 divided by 6 is minus 3y. And then in my last one, here it's a little bit more complicated because I've got numbers and variables as my monomial on the bottom, but the approach is the same. I'm going to divide both of the terms on the top by the monomial that's on the bottom. So I'll split that up first. Notice in that second term, I actually have 2 minus signs. I have the minus sign that's in front of the term on the top, and I have the minus sign that's in the monomial in the bottom. So my first thing that I'm going to do is I'm going to divide my numbers. So 48 divided by 12 is going to give me -4. The next thing that I'm going to do is I'm going to divide my x's. Since I'm dividing powers that have the same base, I am subtracting the exponents. And then I'm going to repeat the same thing with the y's, subtracting the exponents. Moving on to my second term, I'm going to start by dividing the numbers. So here my circle's a little bit bigger. I've got -24 divided by -12, which is going to give me +2. Next, I move on to the x's. Since I'm dividing powers that have the same base, I'm going to subtract the exponents. And then I'm going to repeat the process with the y's. I notice that the exponent is the same on the top and on the bottom. So that means I get y to the 0, which I know is just a 1, or you can think of it as they just cancel out. Those are examples of how to apply the distributive property when you are multiplying and when you are dividing.